Hello, hello. Alrighty. Hopefully my audio is a bit better this time. I did some futzing around with various options. Yeah, that sounds pretty good. Okay. We'll wait for some more people to trickle in here. How's everybody doing today? I'm gonna put my watch on. Been a nice day in Florida. Well, that's good. I think it's thunderstorm season down there, if I'm not mistaken. Something I miss. Don't really get thunderstorms up in the Seattle area, unfortunately. Not very often, anyway. Let's see. There we are. Yep. Yeah, buddy. Cool. Alrighty, so I think I'm going to go ahead and get started. Welcome to stream number 2, where I work on egg boy color things. So for people who were here and were not here, just to catch you up last time, I'm going to pull up Fusion here. Should have had this open from the start, but here we are. Okay, almost there. There we go. Let's see. Let me go back here. Go to Egg Boy Color. Okay, yeah. So for... Oh, shoot. Where did I save that? Well, this is distressing. I would hate to think that I never actually saved that. That seems unlikely. Face reveal. My face has been revealed before. There's no surprises there. Oh, thank God. Okay. Let's see. Yeah, I don't think I did anything meaningful on May 25th. Cool. Yeah, so for people who were here last time and who were not here, for everybody, essentially, this is what I did in the last stream. So basically just started on, the basic shell shape for the Egg Boy Color, which for those of you who do not know is going to be a keychain sized Game Boy Color. So, custom glass lens there, start of some custom buttons, D-pad, all that stuff, front and back shells to fit this like little 1.5 inch LCD I have. And yeah, I mean, made pretty good progress on this. Even have like a little basic PCB shape cut out here. Not going to do that today. So obviously there's more work that needs to go into the shell. There are some people who wish that this was egg-shaped. Maybe one day. But not working on that today. What I want to work on today is electronics. And specifically, I want to work on the electronics for the LCD driver. So the idea is that this is going to be more or less the same as the LCD driver in the Time Froggo color. So it's going to be, small LCD panel. Going to talk to it with an RP2040 over SPI. I've done some tests. This is a 320 by 320 panel, 16-bit color. I think I can get my SPI clocks up high enough that that'll be possible at 60 frames per second. So I can get a nice 2x scale on the Game Boy Color image. So that would be like 320 by 288, something like that. My rough calculations say like, SPI clocks 100 to 120 megahertz, something like that, which is very fast. But luckily I have the advantage of not having to like read from the display. So there's no switching back and forth, which is one of the big bottlenecks usually. So I'm going to proceed as if that's going to work. And so I'm just going to open up KiCad here and going to get started. I think I have KiCad 10 installed, so maybe I don't. So I'm just going to use 9. Let's go ahead and let's create a new folder for this. Going to create a new project. LCD, let's say EBC LCD. Keep all my project names straight from the start here. Cool. So let's go ahead and open up a schematic. This is where all electronic projects start. And I'm not going to do all this from scratch because that would be silly and a lot of work. So let me open up another instance of KiCad here. I do not want that, no. Oh, I forgot to mention specifically what I'm going to be doing. So I'm not going to be working on the motherboard today, depending on how long this first part takes. If I finish this first part relatively quickly, I might do a little bit of that, just do some like, kind of rough parts placement and estimation and stuff. Today, what I want to work on is making a test driver for the LCD. So the idea behind that is I do not want to commit to this super fast SPI speed right from the beginning, build an entire motherboard, get that all wired up, and then find out that my screen doesn't work. So what I want to do is basically build things in small sections. So test LCD driver, test motherboard, that kind of thing. Test them individually so that I can like verify like, okay, this is a problem with the LCD driver, this is a problem with the motherboard, that kind of thing. Instead of trying to jump straight into integration hell and trying to figure out what is causing which problems. So that's what I'm building. So let me go ahead and open up the TFC. No, I don't want to open up the PSP, the PCB rather. Let me open up the schematic here. Yep, and I'm just going to copy paste. We're just going to copy all this right in here. Yeah, we'll use partial schematic. I think that's, yeah, it's because I have like nested pages and stuff. All right. Need to make my schematic size different here. I'm trying to remember how to do that. Let's see. Here we go. We'll do A3. I think that's what I have for the TFC stuff. Yep. There we go. All right. So big chip here. This is the RP2040. That's the microcontroller that's going to be doing the display output. That is the 24-pin mezzanine connector going to the TFC motherboard, so we do not need that. I'll keep these test points for now. Those might come in handy. Let's see. I'm just going to delete the power page. There's nothing in there, but how do I even remove this? Oh, I just get rid of this probably. I don't really plan on having any power stuff built in because this is going to be something that is going to interface directly with the GBC. So I'm going to tap into the 3.3 volts coming off of that and then use that to power the RP2040, and then the LCD as well. So that's the plan there. Let's see. I will need a 50-pin GBC connector. That's fine. I think I have it in my Gekio parts library. Let's see, connector specializes probably where it's at. Yep. Oh, no, it's not. Okay. Let's say it might be in my user stuff. It is not. One of these days I'm going to create a custom symbol for the GBC video connector, just so like I have all my pin numbers and stuff and I don't have to refer back to a data sheet. So yeah, let me go to connector 1 by 50 pin. Okay, we'll just start with that. And then I'll figure out the footprint stuff later. You know what? I'm going to make this even easier. I did one of these boards for the TFC. I'm just going to build off that. I think I made some changes after that, but this is just way too much work. Let's see here. Let me see if I actually saved it anywhere. I don't even know what I was calling it back then. Oh, Time Frog color. Okay. TFC all the way from 2024. See, this is how long I was working on this stupid shit. What is this? What even is this? Oh, this is the GBC. That's the CPU. That's the RAM. LCD connector. Wow. Okay. That's not what I'm looking for. You know what? It's probably one from 2025 because that's when I first tested out. Here we go. Screen driver. Yeah, that looks like it. Cool. I'm going to yoink that. Let's drop that in here. Okay. So this is great. This is the 24-pin connector out to the LCD that I used for the TFC. Not going to use that. So I'm going to get rid of that. That's the reset button. This is, I think that's for the USB header. Yeah, so I'm going to keep that because I can reuse that from the same driver board that I had. Let me see if I can find an example of this board that I'm talking about too. Oh, yes. Ugh. What an unpleasant sight for the masses. No, I'm not using KiCad 10. I thought I installed it, but it didn't seem to be anywhere. So this is the TFC version of this same board. So that's just like the RP2040 on there, the flash, there's the LCD connector for the little TFC LCD, and then round back there is the 50-pin connector that connects to the GBC. And that actually looks like I did build the USB port into this. I did not have a separate header. Let's see, what is this chip? Oh, that's the flash. That's the flash for the RP2040. And there's the USB port. Cool. And then all my test points, going to keep those. Cool. Let's kind of center this up a bit. Let me make sure all my stuff is in order. So we have all of the data pins from the GBC LCD connector coming out here. So we have like our reds all the way up through our blues. We have the data clock. I think this is horizontal sync. This is vertical sync. And then we're feeding these all into like GPIO on the RP2040. So all of our image data right there. We have our SPI stuff here for talking to the LCD reset. And then this is where we have the GBC timing stuff coming in. So there's our data clock and then horizontal and vertical syncs. So that's good. Yeah, so I think the main thing that I have to do here is just adapt this to the LCD that I have, which doesn't use a standard flat flex connector. So it uses like one of these little low profile 24-pin mezzanine board-to-board connectors. So gonna have to wire it up that way. So let me go ahead and pull up Mouser. So I think I've identified a working connector for this. Unfortunately, it seems like these panels are relatively old, and the male connector that they have on the LCD is not produced anymore, and it doesn't look like the corresponding female connector is produced anymore either. But I've been going around. It looks like it was maybe a Chinese clone of this Kyocera part, just based on like all the dimensions that I've taken. And so I am going to get the footprint for this, and I'm going to build around this. All right, down the CAD models. Please don't steal my information. There we go. And I have this cool like Symaxis library loader that's connected to Mouser. So anytime I download a footprint from Mouser, it'll automatically detect it and then throw it into my KiCad library, which is super helpful. All right, so in theory it should be in here. Let me see, what was the part number on that? There's a bunch of numbers. Thank you, Kyocera, very helpful. Let's see if we can find it. That was open already, so probably needs to refresh. And it's still not showing up. Let me go down to the Symaxis folder, which is where it puts everything by default. Let's see. Where are you? Starting to have a suspicion that the library loader is putting this into the folder for an earlier version of KiCad, potentially. Library loader KiCad. Interesting, okay. Well, then I'm gonna close this out and we'll just see if it's a caching problem, I guess. This is the worst part of this electronic stuff, in my opinion. It's trying to keep my footprints and my symbols straight. It's just impossible. Now it's still not there. Interesting. One moment. Manage symbol libraries. Let's see, where are we pulling this stuff from? Let's see. Symaxis is in here. Why are you not in there? What do we have going on? It was updated today for sure, so that symbol should be in here. I wonder if it's named something different. So I feel like sometimes they do that. This really sucks. Let's see, what was this file called? No, not that. I don't need your data sheet. Lib. Okay. Yeah, I mean, it's just the number. KiCad. It's like the models and stuff. Hello. Welcome to the stream where I try to figure out why my footprints aren't showing up in KiCad. Oh, lordy. Two, 4, 5, 8. This is ridiculous. Hello, hello. You know, sometimes these things are like malformed. I think I might just do, for the sake of like getting somewhere, I am going to use, I'm just going to use a generic 2x12 connector. So that'll be essentially 2 rows, 24 pins. Is that not a thing? Uh-huh. 2 by 12. Counterclockwise. I think that's what I want. Okay, let's go with this. Cool. So get that in there. And now I need to take a look at the data sheet. I need to see how all this stuff is actually supposed to be connected. Oh, thank you about the t-shirt, yes. This was the special bit-built t-shirt for Midwest Gaming Classic 2026. Shout out to Crash for organizing that. All right, so we have our pin assignments here. So this is for the LCD. Pin 1, ground. There's a bunch of grounds here. A lot of these just don't connect to anything, so that's nice. You know, SPI, a relatively simple interface. Makes it easy. And let's see. I am just going to hope and pray, and I'm going to double check this later, that the pin numbering on my footprint matches up with the way that it is on the LCD. And I'm definitely going to double check that before I actually route anything. But just for the sake of like getting started here, I'm going to start with this. So let's see. And we need pins 1, 5, and 12 to be connected to ground. So let's go ahead and take care of that. Steal my ground symbol from over here. And definitely do not take anything I'm doing as like, you know, solidly educational. I am not good at this, certainly not at schematic layout. You can see what a mess this is. Granted, this was a prototype board, so you know it's a bit different, but they don't get much better, to be perfectly honest, and you'll all see that when I finally release the Time Frog color boards. All right, so we got a reset pin. That is presumably the reset for the LCD. I think I do have that accounted for on this schematic here. Let me see. Yep, we got LCD reset. So that was pin, what was that? Pin 2? Okay. Let's see, I need a bit more space. Drag that out. Okay. Alrighty. And then, so 3 and 4 we can skip. 6 to 11 we can all skip. So SPI clock, that's going to be on pin 13. We do already have a global label for that. So I'm just going to connect that up here. I'm going to skip the SPI inputs and outputs for a second because they do not make a whole lot of sense on this data sheet, unfortunately. I was studying them for a solid 30 minutes prior to the stream, and I was like, there's some shit is messed up. But a lot of this stuff, at least, we do know. So let's see, 17 chip select. We do have a chip select, thankfully. So that's pin 17 there. We're going to connect that up. I will get back to the power because that's another one of those things that's potentially messed up. Pin 19, that's Terra effect. And so for LCD controllers, that generally corresponds to the vertical sync. So the LCD, I believe it's this way. So the LCD will output a pulse at the frame rate of the panel, and the microcontroller is supposed to listen to that and then not actually start writing until it sees that pulse. And that makes sure you don't get any tearing by like, you know, starting your write halfway through the frame and then all of a sudden you're on a new frame and you're writing to the top half of the screen, something like that. What did I say this was? Pin 19? Yes. So we're going to connect that up. And then we have the LCD power and ground. So those are pins 22 and 23. I did already check. So it looks like the backlight on this LCD is, yeah, so it supports voltages between 2.8 and 3.4. So we can just wire this right up to 3.3 and we'll be good. So let me go ahead and take my 3.3 point from over here. Let's see, I think that said, was it 22 and 23? Yeah, so 22 is the anode, 23 is the cathode. Stop. Okay. And then for now, on the Time Frog color, what I've done is the cathode is actually hooked up to an N MOSFET, and then I can turn that MOSFET on and off using the PWM on the RP2040, and that helps me control the backlight. In this case, for this prototype board, I don't really care. I'm just going to have it turned on full blast all the time. And then, once I make the final board, I can actually, wire that stuff up normally. But for now, no. Let's see. Do I have this screen with me? Could you see just how tiny it is? Yes. It's right here. It's 1.5 inches. It's slightly larger. So I think the TFC one is 1.3. So it's slightly larger than that. But it is 320 by 320, which is nice. Get a 2x scale on that. And then you can see compared to the OEM Game Boy Color, I would say it's, not quite half the size. It's a little bit more than that in terms of linear dimensions, but it is quite small. But it should still be pretty usable. Want to make a G-Boy normal size with a tiny screen in the center? You should do it. You should make a DMG with the smallest LCD you can find. Cool. All right, so I need to get back to these pins that I was ignoring before. Okay, so we have our SPI clock hooked up, I believe. That was pin 13. Yes, we have that hooked up. I think that the one they have marked as SDO here, so it says it's also the display data command selection pin and 4-line serial interface, so that would be SPI. That's pin 15 rather. So I think that will connect to this one. And then, let's see, SDA, serial input signal in SPI. So I'm assuming that's just going to be the SPI data input. So we're going to hope and pray that that is correct. And I'm just going to hook up the SPI data pin here. And in case it's not clear, so these are just labels that help me route signals from other parts on the schematic without having to like draw ridiculous lines, like crisscrossing everything. So you can see my labels here, and then I have the corresponding labels over here coming out of the RP2040, and KiCad Smart, it connects those together. So like when you go and you want to route your PCB and place things, it knows what's connected. It'll show you like where you need to run your traces, all that kind of stuff. This is just a nice way to like declutter the schematic. So I think the only things that I have to do now on the LCD are the power inputs. And this is the part that was really confusing me. And I can't tell what is correct, and there might actually be multiple correct answers. So it mentions here that there's an IO VCC of 1.8 volts. Pretty common to have IO voltages to be lower than system voltage, or not necessarily lower. They may be lower or higher, but like different from the core voltage. And then pin 20 here is VCC 2.8, which is the power input, presumably for the controller. I think the ST889 is what this is. But then we go down here, and the logic supply voltage has this pretty wide range. So it goes from like negative 0.3 all the way up to 4. There are logic levels here. So like input high is 0.7 VDD all the way up to VDD, which would be up to 4. And that's what I would consider to be IO. So that's input output. And it's the same story for output. So I'm trying to figure out if this thing is actually 3.3 volt tolerant, and if I can just put that everywhere. Because that would definitely save me on a lot of hassle. Because then I don't need to put any power circuitry on this board. I just pull the 3.3 right off the Game Boy Color, and I'm good. But I might play it safe. So yeah, I think what I'm gonna do is I'll probably use LDOs for both of these. So I will take, I'll get like a 1.8 volt LDO and then a 2.8 volt LDO. That's obviously not very efficient. And the Game Boy Color is going to hate that because the LDO, the 3.3 volt rail is run by an LDO with a max current of like 50 milliamps. That's what it's rated for. So you know, this is going to be powering a lot of stuff. Like it's going to be powering the LCD, it's going to be powering the RP2040. It's going to be way outside of its comfort zone. But when I did this with the TFC, it did work. So I think I'm going to do that. So let me see. Let's see if we have. Let's just look for LDO. You know, let's do this the correct way. I'm going to go on Mouser and find some parts. You get to peek at the part selection process. Let's see. So what I want to look for is, I think it's going to be under semiconductors, ICs. Should be a power management ICs section. I think that's what I want. Let's look for, let's see what I want. Voltage regulators and voltage controllers. That sounds right. Here we go. LDO voltage. What is the difference between that? I'm just going to go with LDO voltage regulators. That sounds right. Let's see. Let's look for SMD ones. I like SOT23s. They're very easy to deal with. So that's what I'm going to look for. Let's just look for SOT23s. Very simple parts. And let's see. What I need is, I need a output voltage. Where's my output voltages? Oh, here we go. So let's see if we can get a 1.8 volt first. Yes. So let's look for that. 24 parts. Let's see. Microchip technology. They make good stuff. Okay. At least I think they do. I'm not super well versed in this stuff. What is our max current output? 250 milliamps. That should be totally fine. I don't think that's going to be a problem at all. I'm not too concerned with this. I'm going to go ahead and add some of those to my cart just so I know what I'm working with. Grab the footprints here. Allegedly, it added that to my library. So cool. That's our 1.8. And then let's go look for a 2.8, which seems like kind of a weird value. I can't say that I've ever seen that before, but you know, what do I know? I'm a terrible software guy, not a terrible hardware guy. Well, I am a terrible hardware guy, I guess. Here we go. 2.8 volts. It is available. Oh, also 24 of those available. Okay. Let's grab another microchip part. This one, 250 milliamps. Yeah, that's should be perfectly fine, just like the last one. Oh, this one's even cheaper. This is like 51 cents instead of 75. Incredible. Okay. So there's an MCP 1700T. Okay. I mean, I think the other one will be a similar part number rather. So let's see if they actually showed up. You go to my semi-access folder. MCP, where are my parts? This is clearly not set up correctly. Search for parts. Oh, woe is me. Well, I mean, it looks like they have stand-ins for these parts at least. So that's something. It looks like this is what I want. We'll see if when I get around to the footprint stuff, if it actually has the correct footprint for it. But and then it was a 1703, I think. So 1703 AT. Let's see, it's an 18 CB. I don't know what that means. Let's just let's go with this. Okay. That may not be correct, but We can figure it out in post. So this is the 1.8. Let's see, so we got voltage input on the top there. All right, so these are just going to be fed from 3.3 volts. All right. And then we need our ground connections. This is the really nice part about LDOs. You know, there's so many of them. They're just 3-pin parts. Basically brain dead, simple to implement. All right. And then, yeah, so let's see. Now what I want to do is I want to add nets for my new voltage rails. Let's see. What do they call this? Well, let's look for plus 1V8. Okay, we got that. So I'll insert that. The directions are wrong, but that is life. I'll clean this up later. Who am I kidding? No, I'm not. And then 2V8. Okay. Here we go. Wow, gross. All right, let's go back to the data sheet here. So pin 18 is 1.8, pin 20 is 2.8. Okay. What? I'm going to try and have these up here where they should be. I hope the real E's in the crowd are proud of me. They're not. So crowded. Okay. And 20. Okay. And this is just a frightful mess. Okay. And now let me just verify that all these unconnected ones are correct. So pins 3 and 4 should be, they're no connects. 6 to 11 are no connects. That is right. And then 16 and 21 should be no connects. No, 16 is RS, Service Commander Parameter Select. God, who even knows? This data sheet sucks. And then 21, no connect. Okay. I'm happy enough with that. So we'll just roll with that. All right. So let's see. That's just a switch. I don't know if I really need anything else for my little test here. I think everything should be hooked up the way it should be. So I got my USB port. That's all fine. I didn't touch that. Reset button's fine. Didn't touch that. Didn't touch the flash. Cool. Yeah. I mean, I think this will work okay. Let's go ahead and go through the footprint assignment tool. Loading footprints. Why are you taking so long? All right, let's see. J3. Why would J3 not have a footprint assigned? That's weird. I definitely have one in here somewhere. Yeah, let's see, 4105. This is just like a generic port. I don't know why it wouldn't be there. Okay, well, let's see. Let's go to connector. Let's see what they got for the default stuff. USB, USB-C receptacle. Yeah, there we go. That looks like it should be compatible. That should be fine. J1. Okay, so that is my little mezzanine connector there. Let me clear that out. So I did get the footprint for it, weirdly enough. I don't know why the symbol isn't showing up. There must be maybe the symbol is malformed or something. But if I'm not mistaken, that is definitely the part number for the connector I chose. 245804. Yeah, that's exactly it. Okay. And U2, I think that's the flash package. I don't know why that would be missing a footprint as well. Very strange. My whole situation is messed up and it's very sad. All right. I am going to go ahead and jump into the PCB mode because one of the things that I need to confirm is that the mezzanine connector pinout is actually correct. Otherwise, I'm going to have a very bad time. All right, let's go ahead and update from PCB. Get all our parts in here. Lots of errors, whatever. Okay, so there's my mezzanine connector. All right, what are we looking at here? Oh, no. Oh, no, they number this so weird. God, is that really the case? So it's not like a clockwise counterclockwise thing. It's like pairwise across. So it's 1, 2, 3, 4, 5, 6. Well, you know what? Let me see. I'm pretty sure that they do show the pin numbering. Yeah, so this is very clearly, this is actually clockwise for the male one. Yeah, so it goes 1 to 12 in this corner and then 13 to 24. So none of my pin numbering is, oh God, none of it's correct here. So I have to fix this. This whole project was a mistake. Okay. Well, I'm going to get my data sheet opened on another monitor here just so I can have something to reference. Jesus. Okay, let me figure out what these would apply to. So technically this could go either way. I am going to assume that pin 1 on the LCD is going to go to pin 1 on the mezzanine connector. So that's going to be my reference point. And then I need to do some flipping. So basically that is going to be 24. Oh man. I'm like really bad with spatial shit. And now I have to figure this out. Or not, actually. You know what? What I'm going to do is... let's see. I'm going to swap this out for a different symbol. I bet they have a better matching symbol for this. Let's see, connector. Oh, where are you? Was it under generic? Yes, okay. 0, 2 rows. Let's see, 12. How do they do this? Row letter first. Nobody cares about that. Aha! This looks like what I want. Go away. Okay. Yeah, okay. Just plop that in there. Luckily, it's smart enough to reconnect everything on its own. Okay. Okay. All right. Let me update my board here. And did that actually do anything? Let me see. So let me look at the data sheet again. So it looks like pin 1 is a ground and it should be right across from pin 2 in this case, which would be reset, which means, according to my data sheet, if that was actually correct, pin 24 would be reset. I don't think that was right. Yeah, no, 24 is a no connect. Reset was pin, the actual pin 2, which would be there. All right, pin LCD reset would be pin 3 here. Let me go back here. Am I reading something wrong? No, I don't think this actually updated. That's weird. Might have to reassign the footprint and maybe, yeah, no. Nobody has come to my rescue, so sad. Let's go back to the footprint assignment tool. Yeah, so I have to reassign the footprint, of course. Okay, let's see. So back to some axis. And then there we go. Okay. Now it should be good. Very cool. Okay. Yeah, okay. So let me just do some window snapping here so I can get these side by side. So we have, and I think this is correct. So over here, this is the view looking down onto the connector. This is also a view looking down onto the female side. So technically, if you were to flip this one over, the LCD connector, one would be on the left side like it is here. So that would go to ground, which is correct. Let me rotate this. There we go. That's better. Yep. And then pin 2 would be reset. So that'd be LCD reset. Pin 2 would map to 3 here. I hate this. I hate everything about this with every fiber of my being. I'm just going to forget about those pin numbers. I'll probably actually renumber the stuff on the footprint at some point, but not today. And then the 3rd and 4th are no connects. The 5th is a ground. A bunch of no connects. The 11th is a no connect. 12th is a ground. Okay. And then let me go ahead and sync up with pin 24 on the connector here, which is a no connect. That is correct. Pin 23 should be ground because that's cathode. Yeah. Yeah, I think this is correct. I think I got it. Yeah, yes, you should make a mouse order. Please buy me some things because I forgot to buy some stuff in my last order that arrived literally just like 2 days ago. Because I'm a silly goose. Cool. All right. Back to hell with you. Okay. So, I think, let's see, is there anything I'm missing a footprint for? There is, yeah, I'm missing the flash footprint. That one's important. Let me see if I have one on hand. I don't remember which flash I'm using here, actually. Let's see, so that is the W25Q. I think that's one of those pretty big flash packages, if I'm not mistaken. Just gonna go to Mouser and see if they have it. They do not. Okay. Do they have like variants of it? They do. Is that the one that I'm actually using? I'm trying to remember which one I actually used on. Let me open up my dev board again. Let me see. Yeah, of course it doesn't show up in recent. Gosh, darn it. PCBs, time frog color, screen driver. Here we go. I'm just going to keep this open from now on. What footprint? I don't know why the footprint would be available here, but not working on the other one. All right, so this is, what footprint is this? This is just a generic SOIC8. Okay, I'll just do that, SOIC8. Let's see. Back to the footprint assignment. Let's see, SOIC 8. And then it was a 5.23. Presumably 5.3 is the same. Let's see, what is the specific one that I'm using here? 5.23 by 5.23. I think it's good enough. Probably. This doesn't need to be perfect. This is, yeah, I mean, that looks like basically the exact same thing. What in the world, man? Wow, okay, anyway. There we are. So I got a bunch of shit here. I think I have everything I need. So let me go ahead and make a board. Let me see. I'm going to go to the edge cuts layer. It's going to create a square. Yeah, let's just do a nice 40 by 40, you know, a reasonable size. I'm going to put this over here so it's not interfering with anything. And then I like to fillet my edges because it's beautiful. Okay. So here is the GBC LCD connector. Yeah, that's fine. Okay. I'm going to put that near the top so that doesn't interfere with anything. And then I think USB we'll put that later because I need to lay out the whole RP2040 thing first. So let's see, what do we have here? This does need to be oriented a certain way because, you know, something like the USB lines have the ways they like to be routed, and the flash has ways it likes to be routed. Okay, so we'll say that the RP2040 will be like this. USB is going to be on the bottom. Where's the flash going to be in relation to all this? It's going to be this side, so probably just like, yeah, sure, why not? Somewhere around there. And then get these resistors in place. Those are the right way around. Very good. If I remember right from the RP2040 documentation, they're like, you should have these resistors as close to the RP2040 as possible. I'm too stupid to know why, but that's I'm going to carry that over. All right, I think those might actually need to be farther away because we're going to have some power stuff coming in there. Let's see. This should not be on the edge. Let's just bring that in a little bit. Okay, that looks fine. Let's see. That's the clock. Okay, where does the clock hook up? 3.3. 3.3. Okay. I may actually put the GBC LCD connector on the other side, potentially. Maybe. It really depends on how this goes. All right, let me just kind of line that up there. Okay, that's fine. Cool. That's probably not fine. That's probably terrible. That is, what am I doing? What is this? It's so big. That's absolutely the wrong footprint. That's, okay, interesting. That's for my 1.8. Yeah, okay, fine. Get out of here. That was apparently not the correct part for that. let's just do the TT. I think that should be the correct package at least. All right. Update my PCB again, and hopefully it'll let me drop in. Yeah, there we go. That looks like a SOT 23. That's the way it should be. Yes, my workbench is terrible right now. I was doing more silicone casting yesterday. I'm getting much closer to like an actual atomic purple on the watch band. I think this needs to be just slightly darker, but way closer than my previous attempt. Like it's not even close. Not even close. All right, what was I doing here? Let's place the mezzanine connector. So where are these inputs coming out? So it looks like all the SPI stuff is coming out of this side for the most part. So let's try and have this aligned as best we can with that. Yeah. And honestly, I don't really care in this case, having this stuff oriented in a way that makes sense for like a functional thing. I think it's going to be easier to route. I'm just going by what's going to be easiest to route. And I think that's looking good. Look at that. All my SPI stuff lines up pretty nicely if I do that. Okay. I just need to make sure I actually plug the LCD in the right way around because these things generally are not keyed. Okay, so I think these... Oh, you know what? I forgot about this. I actually should have some filtering caps for these LDOs. Okay. You know what? I want to actually flip this, mirror this vertically or horizontally rather, because then I can have these poking out in opposite directions, and it's beautiful. There we go. Okay, and then I can have my, let's see, I'll just do 100 nanofarad, something like that. That seems reasonable. I'll actually look into what I need later on, but this will do just fine for now, probably. Let's see, move that in. I'm going to have my Nets Kiss. Ooh, mwah, mwah. Okay. I just want that space for the caps here. All right. 100 nanofarad should be fine. Let's do 1. I remember my 3.3 volt LDOs from other projects. They had one microfarad on the output, so we'll just do that. Cool. All right, so I gotta go assign footprints to these. I want these to be easy to hand solder, so these are just gonna be SMD 0603s, I think. Those are generally pretty easy peasy. So there we go for all of those. Okay. That is the wrong board. Alrighty. There we go. Let me pull in my 1.8 here. So where's that one gonna go? We can put these on the other side of the board as well. Why not? Alrighty. I don't really like that being that close to the... You know what? I'll put them on top. They'll be right over these guys. The only reason I don't want them like right next to the RP2040 like that is because I'm probably gonna have a bunch of vias in that area potentially, and I don't want to have to like work around the pads for these LDOs. So I'm gonna do this. Sure, why not? There we go. That looks fine. Maybe. I think I can make this better. No, I'm not going to bother. Let's see. Where's all my filter caps? I really need someone who knows what they're doing to come in here and yell at me. Otherwise, I'll never stop doing this. That is the output cap. No, that's the input cap. For that one, that's the other input cap for this one. Or rather, the input cap for the other one. Alrighty. These should be the output caps. That should be good. And then output cap for the 1.8, I think. Yeah. Look at that. Look at that. Okay. Cool, cool, cool. Let's see here. Let's go ahead and get this switch placed because that's kind of a big part. Annoying to deal with. Let's see here. Oh, and I don't think I mentioned what this is for. So this is the reset switch. So if I hold down this button when I plug the board into USB, it'll put the Pico into flashing mode, the RP2040 rather. So if I need to flash the firmware to it, which I will first time I build it, and also when I'm developing, I will need that. Okay. Ah, there we go. That's fine. It's right on the edge of the board, but I don't care. This isn't about looking good, it's about working. What is this one? Okay, this is a decoupling cap for the 1.1 volt rail. I think I'm just gonna put these all on the other side of the board. I don't think it's gonna be a big issue. My dirty little secret is that on the Time Frog color, I'm not actually populating all of the decoupling caps for the RP2040 that I'm supposed to be. There's some on the opposite side of the board from most of the circuitry, and I'm like, that might actually short out against the metal shield of the LCD. So I'm like, I'm just gonna leave them off, and it's fine. So yeah, I'm going to put this also on the other side. Okay. Now I think the tricky thing is here, some of these are different values if I'm not mistaken. So that's a 1 microfarad. That seems right for that. That's 100. So I think that's, just one that goes to the individual pins. I think there's a 1 microfarad that goes from 3.3 to ground. And that one goes on that big chungus. There we go. Yep. Yeah, so this goes on this corner one here because there's like 3.3 volt pads here. And then I'm just going to kind of plop that down here, and I'm going to use a fill to get that all connected. Let's have a big ass piece of copper there. Okay. Why are these 0402s? Why am I doing this to myself? Let's see here. So another 3.3 decoupling. All right. Another 3.3 decoupling. We'll put it there. Okay. I would like to say there was some rhyme or reason for, there definitely is. for what is this part for? Oh, this is something to do with the flash. Interesting. Okay. That is like select line or something. Let's plop that there. It's fine. It's fine. You keep getting make hair ads with my stuff. I did let them use it. They did ask, but I would like them to sponsor me or send me a Z1, please. Please. They even used a picture of the wooden Tadboy back with their Z1 Kickstarter campaign. Which, you know, I'm very proud of that, but it would be nice to get a bit more because I'm a greedy man. Let me move that over. I need to squeeze this. Psh, courtyards aren't real. I don't think I can name a single time, even when doing PCBA assembly. For those who aren't aware of the acronyms, where the overlapping courtyards, these pink areas, actually mattered. JLC just kind of ran with it. You know, PCBWay just ran with it. They're like, that's fine. All right, this one's going to go on the back. Okay. I have a strong urge to just not even bother with my whatever. What was the layout of things here? I mean, this seems mostly the same here. Oh, I have my flash oriented differently on that one. Wow, look at this. Look at how clean I was. My God. There's 4. Oh my God. There's like 3 decoupling caps in this corner. It's 100, 100, and a 1, presumably. Wow. These guys are going to kill me. Okay. If you insist. Just going to plop it down right there. Going to plop another 2 down there, apparently. It would be kind of fun to test the limits, like how functional of an RP20 board could I make with basically no decoupling caps. I'm sure you could get it working at least at low speeds, but it would not be happy, I gather, I imagine. I expect. I am, wow, man, where does this other 1v1 one go? I've got a 1v1 decoupling up there. I've got one down here. Maybe I'm supposed to have 2 down here. What is that? What's the value of you? That's 1 microfarad. Did this one have 2 in that area? Oh, I'm missing one down over here. Okay. Interesting. Interesting. It's not that interesting. Egg, yes, egg. We will plop that right there. That is fine, probably. I'm assuming one of these is going to be for the flash, so I'm just going to go ahead and put it there. Let's see, I'm probably missing some 3v3 pins somewhere. I got one there, I got one on that. I have one for that. do not have one there, so I need to plop one down there. It's gonna slightly offset because I'm probably gonna have traces running that way. And then I have one more. What the hell does this go to? I'm gonna leave it out for now. All right. So let me see. I need to set this up as a 4-layer board because I'm not. Oh God, I can't do 2-layer anymore for most things. Except for the TFC charge board. That was pretty straightforward. And that one's 2 layers. They're not even that much cheaper. There's like so little point in using 2 layers at this point. Unless you're a real bean counter. Okay, I've got my inner layers now. There we go. Let's see how horrendous this looks. Wow. Like I would still have the the flex PCB color selected. I mean, that looks okay. I can make this board smaller. I may actually, just for fun. It always looks so weird if it's big and you only have a few components on it. Let's see here. Okay. And then test points. Oh, I do have test points though. So I'm just gonna put these kind of, I think on the other side. Just kind of arrange them neatly here. So we'll get a ground and our powers will be right here. I should probably add 1.8 and 2.8 test points. I think that would be wise. Oh, these ones, where should these go? These should probably go up here. Because the only thing I'm doing here is I want to be able to easily inspect and verify that I'm correctly getting like my color signals in. It's like a sanity check thing exclusively. That's the only debugging value it has. But you know, it's good to know. It's nice to know. And then I will apply proper labels to those at some point. More room for PCB art. That is correct. That's true. So I could put a big frog on here somewhere, a bunch of big frogs, a bunch of small frogs, lots of small frogs. This is the DCK. That's another one that purely for testing this. The connection to the FPC and 1.1. I mean, that's helpful. That one can be helpful. Just to make sure that like the RP2040 is super nice in terms of like implementing it into things. Like it's a relatively small amount of external components that you need for it outside of all the decoupling capacitors. But the core voltage is actually 1.1 volts. However, you can get away with only giving it 3.3 because it has a built-in LDO that'll drop the 3.3, which is generally used for like the IO voltage, down to 1.1 for the core voltage, which is super great if you want a simple layout. For the Time Frog color specifically, I did not want to do that because I knew that the core was going to be doing a lot of work. And so I didn't want its main power rail being dropped all the way from 3.3 down to 1.1 with an LDO. I was like, that's not super efficient. So I actually did go with a switching power supply for that. But in this case, again, development board. I do not care. I will care for the final one. The final one will for sure have a LDO, or no, a switch mode power supply for 1.1 volts, just like the Time Frog color does. But not gonna bother with that now. Oof. Ooh, look at this. I'm gonna tessellate my test points. Testillate. That doesn't sound right. That didn't sound right at all. Okay, the only thing I have left to place is this last decoupling cap. Where the hell is that? Oh, wait. No, I don't know where this goes. I'm just gonna put it in. Where am I gonna put this? I might just get rid of it. I don't think there's a pin I'm missing here. Oh, that's for the clock. That's for the oscillator. Brilliant. Okay. Very good. So smart, Chris. So smart. Okay, so now I can start to actually route things, presumably. I think this will work. I think I can make it work. So what I want to do first, because I want to get rid of a lot of these lines that are for like grounds, I'm going to draw a filled zone. I'm going to change my grid size just to make that easier. So this is going to be the ground pour. I'm going to put that on 3 layers. There will be a dedicated internal one, and then I'll just also have it on the outside layers. I think in one, that's going to be power. So that's going to have like 3v3 and 1v1, 1v8 and 2v8. But this one will be ground power. So let's see. I don't need a lot of clearance on this. 0.3. No thermal reliefs. I can't do that. Thermal reliefs just tend to make everything a lot harder with the stuff I work on. And it's at such a small scale generally that they don't actually provide me a whole lot of benefit. So I'm just going to not. Well, I mean, I guess that big ass ground pad there might cause some problems, but I will cross that bridge when I get to it. Also, I didn't have any problems with that anyway previously. Cool. Okay. Let's go ahead and hop to the top here. Let's just start connecting things. So I don't need to worry about USB power. I just need the data lines. I am going to go ahead and connect this. So let's see. Oh, this is actually flipped around. That's not correct. Okay, now it's correct. I am going to set up some net classes. Or rather, just some predefined sizes. All right. Oh, I also want to set my minimum. Just so I can have some smaller vias. Let's see. So 0.3. That should be a nice chunky, yeah. Everything is like, oh, they should be chunky. They should run exactly parallel to each other. Blah, 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 blah. Electronic engineering is not real, so it's fine. It's fine. It's basically magic. Let's see, 0.3 mils, that's way too big for those. RP2040 connections, so I think most of these, they'll just be 0.5 or 0.15, 0.5. That would be crazy business. All right. I feel like I can actually set this up and keep it KiCad to be a differential pair, and it'll probably keep them together, but I'm too stupid for that. I don't know how that works. Let's see, I'm gonna connect. That is so big. It's such a big via. Sure, whatever. Why does that look so weird? Why is there no hole? Oh my god, because I'm an idiot. I have that backwards. There we go. Okay. All right. Actually, you know what? What I want to do first is I want to get a pour for this big 3v3 thing going on here. So select the 3v3 net. We'll just call this RP2040 IO fill, something like that. That should be fine. Small clearance on this, maybe even smaller than that. So I don't have to deal with that. No thermal reliefs, solid fill. Yes, yes, yes. Include all these pads in here. Get a nice 45-degree angle up through here. Wow, so beautiful. Wow, look at that. There we go. Okay. Then we'll come out here. That should probably be fine. You know? I'm going to go ahead and get a 3v3 fill going on in the middle here. So I'm going to create another zone. 3v3 inner. That's all I'm going to call it. Yep, we're on in one. That's good. I'll have slightly larger clearance on it just because it's power related. They're all low voltages though, so it's probably not going to be a problem. Let's see. Yep. Now, let's see. Where do we have 3v3 coming in here? Looks like it comes in from there. So I'm just going to have this bounce out. Change my grid size again. All right, so now my 3v3 coming in from the Game Boy Color is going to feed that inside layer. So now those are all connected, which means all I have to do for these is just connect a trace, drop a via down to the internal layer, and we're good. All right, I think we'll just do that. That's fine. Things are starting to clean up. That's nice. Okay, and then I'm going to connect all my 3v3s as they go around here. Yeah, okay. There we go. That one's on the other side of the board. Let's see. I kind of want that. I'll put it there for now. It should be okay. But I don't know if those traces for the color lines are going to get in the way. We'll see. Connect up the flash power. Please, Mr. Mike Dub, don't take anything away from this. I kid partially, but like, I'm not good. But if you do find it helpful, you know, maybe it's a good stepping stone. Alrighty. All right, reset goes into both these places. Okay, I can just... Cool. Oh, is this going to be... You know what? I'm going to kill that one for now. I don't like the way that that's going in. Okay. I should not have arranged... Oh, no. I think I need to rotate this, actually. I don't think this is arranged the way I need it to be for this to be easy to connect. Let's do it like that. And then, let me see, move my decoupling cap. Alrighty. Oh, I want to use my fat one. There we go. All right. And then, how does this look now? Still bad. Trying to think what the orientation of this stuff is on the other. So let's see, closest to the chip we have QSPI SDO and then ground. And here we have closest to the chip is... No, I mean, I had it right before. I'm just gonna have to roll with it, I guess. Gonna blame me for your future bad designs. Fair enough. I shan't complain. All right, let's see. Let's just start connecting stuff and we'll see how it goes. I could have sworn this connected much nicer here. No, it really does just go around the outside. Interesting. Okay. Oh, that's why, yeah. In that case, I am in fact going to, one of these days, hopefully maybe I'll get better at planning layouts. Like I do some of it, but I'm not great at it. It's definitely one of those tricky things that can be a bit difficult to get good at. I have more than once, for sure, completely scrapped layout and routing because it's absolutely messed up. Part placement. Sometimes it's easier to just kind of start from scratch. Yeah, there we go. That's lining up much more like I was expecting. Let's just get these in nice little bundles. I don't know if that does anything. I just think it looks nice. I'm just going to route these on the bottom. What if I did something stupid like this? Wow, look at that. Don't like the way it's doing that. Just gonna plop it down on the back. Let's kind of have it generally follow the route of the other stuff. There we go. And then this one goes up here. Don't remember what these resistors actually do. Oh no, I do remember actually. One of them is a pull-up for the reset. In fact, it's this one. I think this one's the pull-up. Okay, and then it's not pretty, but it's technically functional, probably. Hey, Subi, don't encourage anyone, or I'll take your TBCs away. And they shan't be returned. Alrighty, let's see what else we got going on here. Oh, right, yeah. Forgot there's USB-C, so there's 2 pins each for these. Okay, and then this one, route around the outside, why not? I really hate joints like that, but it's fine, probably. Alrighty, what do I have left here? So I've got my, oh right, I did move this. Which one of these? One of these is the power. I think it's 1. I think pin 4 is basically the enable pin for this. So I'll just do that. This one, this goes into the clock input on the RP2040. All right. All right. All right, let me go ahead and clear up some of this. just get these connected so I don't have to stare at those lines anymore. Because that's getting annoying. Let's see. So SPS needs to come down there. Yeah, why not? Okay. Let's start routing the video signal in here. Yeah, I can come in front of those because those SPI ones are just gonna go through vias down to the bottom layer. Okay. Okay, so that's SPS. I feel like this clearance is so big. It's only 0.3 millimeters though. Very interesting. Well, this is going to be an absolute nightmare. I did not think this through. Like most things. It's going on the bottom. Move that out of the way a bit. So I can get more room here. I need to decrease my allowed clearances on this too. Let's see. Net classes. Clearance 0.2. I'm going to do 0.215. Oh, yeah, I can set defaults too. That's very nice. Let's see. Oh, actually, you know what? I think I can make my via holes much smaller. I will check that out in a second. Covered edge clearance, let's do 0.3. I do 0.3 for some reason. I think that's from Osh Park. I think that's what their minimum is. I haven't ordered anything from Osh Park in years though. Let's see, minimum clearance. Okay. 15. Okay. Okay. Let's go over to JLC PCB and see what their capabilities say on minimum via size for standard price. Let's see, drill diameter, multi-layer 0.15, yeah. Okay. Let's see, hole size tolerance. So that's the minimum size, but it's more costly. I'll keep it at 0.3. I think that's pretty small anyway. This is the wrong one. Let's see here. God, I might actually move. I think I'm going to move the GBC connector. Yeah, I am. This is going to be a pain in the ass. It's a pain in the ass and I do not like it. The question is if it's going to be on the front or if it's going to be on the back. Let me just clear all these connections out. Okay, let's see here. Yeah, I mean, it's all reversed if I do it that way, but if I flip it, that lines up pretty well. So I'm doing that. Let's get rid of this. Let's actually have this via go back here. Just to give me more space. I can stagger these. I should be able to get them in there a bit tighter. Nope. Let's get rid of that for now. Okay, let's do G0. So that's the last of the green pins. So I'm gonna come around like this. Okay, all right. The great thing about this is these are low speed signals as far as anything modern is concerned. That's like 4 megahertz, 4.1, whatever. So like the routing on these it's not a huge deal how it's done. The SPI ones, though, I definitely want to make sure those runs are as short as I can possibly get them. Otherwise, I might have a bad time. I need to move this down a bit. Okay. All right, and then I think I've got a few more color ones. Yeah, so I've got B2. I don't like the way it bumped that other one out. Again, probably not important, but it's ugly. B4, and then we got B5, okay. There we go. I just want it to be pretty. That's not pretty. Gross. Okay, let's see. So that's most of the signals from the GPC LCD connector. Let's see, what do I have left? Yeah, just the timing signals, looks like. So LP, S2. I do need to move those test points at some point. This is coming up here. And a lot of these I will move them around at some point and get them nicely bundled. Let's go around this way. Makes more sense. And then I think data clock. Where's data clock coming in? Oh, there it is. Whoa, what is that? Oh, that's horizontal sync, okay. Alrighty. Oh man, there's never-ending lines. Let me go ahead and move these. I think I'm gonna move this button. Yeah, I think actually moving it down here makes sense now that I think about it. Just because it's like right next to that. Wait, is it? Yeah, because it's right down next to the reset pin on the flash. Not the superhero Flash, though, just, you know, just the Flash. Let's see. So this one is, yes. Put that there. We get the pull up back. Put it there. That just seems right. Okay, that's, don't need that. Then I need to reconnect that to the, let's see. There we go. Very good. Why? All right. So let's see. I don't remember why I did that anymore. Oh, yes, test points. So these are all. Select the right thing. You are all coming with me. Okay. Yeah, you know, that looks right. Get these back up. Alrighty. That does not need to be connected to anything. I really don't need this. I could put so much art. I'm going to put so much art up there. There's so much space. This stupid GBC connector is just so big. Let me get these test points hooked up before I forget. Let's see. I don't have an internal pour for 1v1 yet. Get around to that. Now, let me see. I think, if I remember right, 1v1 comes out of here. This is the source, I believe. Let me look at the data sheet real quick. RP 2040 data sheet. So it looks like pin 45 is the one that I'm fingering as the 1v1 output. Let's see. Pin out. Page 10. Okay. Way too far. Yes. So pin 45 is the VRig out. So that's the output for the 1v1 from the LDO. So this is right there is where I'm going to start the interfill for the 1v1. Where do I need 1v1 at? I need it up here. Let me highlight the net. This is a nice trick. So net inspection tools, highlight net. So it looks like everything that connects to 1v1 is just kind of in this line here. So I'll probably have like a little snaky thing inside. So let's see. Let's go. Let's see, 1v1. Just call it 1v1 inner. Ooh, small clearance, no thermal reliefs. This is an inner layer, so thermal reliefs just, you don't need them at all. Not at all. Well, I take that back. There are probably cases where it might actually help. This is not one of them, so who cares? The only thing that I have to be mindful of here is that I'm not encroaching on the 3v3 sections too much, because I don't want to cut that off. I'm just going to plop a via there. I'm sure there are actual rules for how you should be handling this, but god damn it if I don't just go on vibes. All right, so now I have my internal layer. Let's go ahead and connect this. So now I can just plop a via down right in there. So now that one's connected, no problems there anymore. Normally with this, I would do like a ground fill off this pin, and I'd have like a bunch of vias and all this stuff. I can't. I'm not bothering this time. Not right now. Oh, interesting. I haven't even connected with 3v3 here yet. I will do it for this one. 3v3. Let's call this GBC 3v3. 3. So let's do 0.2 because it's pretty close to other stuff. Solid fill, no thermal reliefs. That is not where I want that. How does that look? Looks pretty good. All right, so now I got a 3v3 via. Just gonna put a couple of these. That should be sufficient. One more line knocked off. Let's see here. So this decoupling cap is not even hooked up at all, is it? I just totally missed a 1v1 decoupling cap. Doesn't matter. Okay. God, this is gross. Oh no, I do have it. It's right here. You know, if I could be closer, but too late for that now. I'm not doing any major changes for that. Okay. There we go. Drop a via down for that. Connect that 1v1 input. Just gonna drop a bunch of 3v3s here. I'm not gonna have like traces coming off this or anything. Ta-da! This, oh, interesting. I don't know why I don't have one on that. Oh, it's on the other side again. I keep forgetting that I dropped several on the other side. All right. Am I missing something here? Oh, there's a 3v3. Oh, I never actually connected that to that 3v3 plane. All right, so I think that handles the GBC connections. That's all good. Reset's good. Flash is good. It looks like all the RP2040 stuff is connected now, like all the support circuitry anyway. So clock and USB and decoupling caps, all that stuff. Looks like mostly all I have left now is hooking up this stupid connector. So let's see. Let's start with the easy ones. Oh, this looks quite easy, actually. Let's start with that. All right. SPI data. This is very nice. These are just like more or less straight runs. Kinda. That's fine. That's not too bad. Actually, I'm going to move this up a bit, I think. Just buy some space for this. Pull this up a little bit. Yeah. Yeah. Okay. And then, let's see, LCD reset. Where does that go? I'll handle that later. I don't like the positioning on that. Let's put that V on the other side. Okay. So let's see, 3v3, that one's easy to get. Oh, and actually this this LDO can just piggyback back off this pin too. That's nice. Or can piggyback off the VIA rather. Oh wait, ta-da! That's good because that's already got a ground connection there and that one's unconnected, so that's not going to cause any problems. Let's see, 1v8. My 1v8 output is right over there. So that's like hella convenient. Get that connected. Get that connected. Let's see, where's my 2.8? Where's my 2.8 at? Okay. Get that connected. That's super convenient. Why is that ground not connected? Is it this ground or is it this ground that's not connected? No, that one's definitely connected. This one's not for some reason. Oh, I think because, yeah, I think my clearances on this are just too low or too high. Yeah, it's still not connecting. God. Oh, it's because my minimum width actually is too large. There we go. Now we have a ground connection there. And that should be true for all the other ones as well. Yep, okay, that's good. And then, let's see, we got LCD reset that we still need to route. I will run it down here, I guess. This should be a low speed thing, so I don't think it matters that I'm running it around all the power stuff, but you know. Ugly, that's gonna have to go all the way around. But I also don't want to just like cut off huge sections of these planes. Why did I do that? That's on the back. Okay. No, I actually want to route this inside because otherwise I'm cutting off that ground connection potentially. All right. And then tear enable. So that's like the VSync essentially for the LCD itself. I think we should be able to drop. There's no room for that. Let me see. I think I need to drag this. Oh, no. Yeah, I just need to drag that out of the way. Move this up. And then I should be able to drop a VIA in there. There we go. And then what is missing here? SPI chip select. Oh, right. Okay. So I think I'm actually going to move this down. Buy myself a little space. Okay, that's nice. And then, yeah, I can just route this up through here. Cool. Is that it? Let's do a DRC, so the rules check. I'm sure I'll get all sorts of problems. Unconnected items. Okay, so we do have a few of these. What is this for? Oh, okay, so there's another 3v3 here. I don't actually know. I'm just going to copy this up here. All right, that's good. And then, so we got a couple more here. What is this? Oh, these are both 3v3. So you know what I'm going to do is... I think I'm going to create another filled zone maybe. No. It's going to go boop, drop a VIA there, get that connected there. This 1v1 is also disconnected. Oh, because I never dropped a VIA next to it. Okay. There we go. That connects to the inner plane. Why is that showing as disconnected? Something is not connected here. But how? Let's look at our power plane here. Oh, there we go. That's why. Yeah, so it looks like I dropped that 3 volt. VIA, right. Right at the thinnest point of my 1v1 inner pore there. I ended up disconnecting it. So let's see. I just need to run. Just need to kind of move things a little bit. Let's just get it out of the way of that entirely. Okay, there we go. It's not ideal, but it works. We can also shrink this. It doesn't need to be huge. Alrighty. Now, do we have any other disconnected items? We still have 2. Okay, it looks like we have some disconnected ground pores probably. Oh, yes. So it looks like the main thing missing here, I think, is just the fact that the inside ground layer is not connected because I have not actually ran any vias for ground. So that was just totally isolated. So I'm just going to put a shit ton down. Let's see, let's create an array. Let's just do a 5 by 5, why not? Let's make them 1 millimeter apart. Okay, all right. Wow, look at that. So many vias. Still unconnected items, interesting. Okay, it's down here. So I've got a disconnected ground pour somewhere. But where? This looks like the same thing. As far as I can tell, this is all one contiguous piece. Oh no, the middle guy, the middle one. Crap. This is why I was kind of not wanting to run stuff right behind the ground pad on the 2040 there. Forgot about that. Okay. Okay. So now that's more or less free. So what I'm going to do is, because we have our inner layer connected now, I'm just going to drop a whole bunch of, you know what, I'm just going to do this. I'm going to edit the footprint, which is somewhere. Oh, here we go. Let's see. Open in footprint editor. And then I'm just going to drop some vias here. Let's say these are, no. Drop a bunch of vias. Hi. Why are you only going in the middle? All right, so now that that center thing should be connected. That's good. Oh God, I disconnected 1v1 again. Okay. Okay. Let's check again. Still one unconnected item. What is it though? They make this so hard. Something here. If I could see the lines, then I could at least like have an idea. But I don't see the lines. Let me see. Let me highlight the ground net. Hell is that? Okay. Okay, so now I can see all the ground stuff. So this is all one piece here. It goes through there, that's fine. Ah, there it is. There's a little disconnected section here. Yep, okay. Let's drop a ground via there. Okay. Cool. That's that. So now it's just cleanup, but I think I'm gonna end the stream here. It's been about 2 hours, so thank you everybody for joining. Let's just take a look at what I've accomplished. I've made a real shitty board. There's still some work I'm going to do. I'm definitely going to clean a lot of this up. A lot of this is just like, first pass routing. So yeah, I'm going to go through and, probably change anything that's a bit sketchy, clean things up, put some art on there, and then send it off. So hopefully within the next week or two, I will have confirmation that yes, indeed, I can just ass blast this LCD with image data over SPI. And if all that goes according to plan, then this whole thing is on. And this thing is going to work without having to like pick a different LCD or find one that has the proper interface. Because the very annoying thing about this is there's lots of places selling this exact, yes, 2 hours of Froggo. There's a lot of places selling this exact LCD. And they basically all are exclusively SPI. And if I ask, like, hey, do you have a version of this with like a 8-bit parallel? They're like, no. But you can have this 240 by 240 panel. I'm like, bruh. That's like exactly the opposite of what I want. Whoa, look how close those are. I need to do something about that. Probably use a smaller, but anyway, enough of that. Thank you for joining, everybody. I will catch you next time.